Advanced Algebra, Function and Graphical Reasoning 3.1. Okay, so we're going to look at first how to find an inverse. And people do this different ways, so some of these steps you may not do. But usually it's presented as f of x or in some sort of function notation, maybe g of x, h of x, and so forth. It's better usually to change that label to a y. You want to then switch x and y. Some people don't actually switch, they just solve for x. But I usually switch x and y because it helps with understanding graphs and tables if you do that. Solve for y and then change y to the inverse notation. This is read f inverse of x. There's no computational significance to that native one. It's just a notation. For an example, simple one, f of x equals x plus 6. Let's look at our steps. Step 1, change f of x to y. Notice the color coding. Step 2, switch x and y. Okay. Step 3, solve for y, so subtract 6 from both sides. Step 4, this is our answer. F inverse of x is x minus 6. And notice right away that quite simple. This is one that would be easy to just know without really showing steps. The inverse of adding 6 is subtracting 6. And what an inverse is basically is kind of like a control Z or undo function on a computer. If you were to add 6 to a number and you wanted that number back, you just subtract 6 from your result to get your number back. For example, if x were 9, 9 plus 6 is 15. Well, if you want your 9 back, just subtract 6 from the 15, you get the 9 back. Second example, f of x is 2x minus 1. Again, change f of x to y. This time, no color coding, switch x and y. Now we'll begin to solve for y. So I add 1 to both sides, divided by 2. And on the next slide, this is where we left off. You could, some people don't do this, but you could put that 2 on each one, become 1/2 x plus 1/2. And then finally, again, f inverse is 1/2 x plus 1/2. Tables of inverses. Okay, so if you're given a tabular format, inverses will have inverted x and y coordinates. That's why I like to switch x and y when I do it analytically. Okay, so here's an example of a function that's inverse. Notice the switching of the x and y coordinates. Okay, third example, provide the inverse of f of x. And you may recognize this to be x squared, 1 squared, 2 squared, 3 squared. Well, the inverse would be the square root. Okay, 1 to 1, 4 to 2, 9, just switching the coordinates. Graphs of inverses. Okay, the graphs of f and f inverse are symmetric about the line y equals x. Okay, here's a picture of that. Y equals x is just from simple linear algebra. Y equals 1x plus 1. It can be thought of as a 45-degree angle with a positive slope through there. And notice the red and the blue are symmetric to that, which means if you were to fold along the green dashed line, the red and the blue would coincide. So fourth example, graph the inverse of f of x. Okay, this is actually a logarithmic function that we'll get to later. There's a couple ways you can do this. One way would be if you can picture the symmetry, which we have here. Here, the purple line is the symmetry. And notice the green and the red, where they intersect is right on the purple line. And if you were to fold along the purple line, this red curve here would land on top of the green, and this piece would coincide, and these here as well. Now, if you're not comfortable with just making it symmetrical, you could pick out some points. Like, for example, it appears to go through 1, 1 here. And you could just switch the coordinates of 1, 1. Well, 1, 1 switch is just 1, 1. And also say the point 2, 4 here. Well, if you'll notice, it goes through 4, 2. 4, 2 being right there. So there's 2, 4. Here's 4, 2 on the green. So that's another technique, is to find a few points and switch the coordinates like a table. Okay. So the standard here for F.G.R.3.3.1, find the inverse of exponential and logarithmic functions using equations, tables, and graphs. Now, we didn't say anything about exponential and logarithmic, just briefly referred to graph as logarithmic. The future standards here go into plenty of detail about those, so I just saved that for a future standard and let this standard mostly just talk about inverses.